Hi guys. So in today's section, before we get started, I wanted to show you a little demonstration. So last time we talked about circles, and when we talk about circles, we know that there's a center and there's a radius to it. So I wanted to show you a little demonstration of how a circle works because it leads into how this section works. Before we even start, let me just brag a little bit about my setup right now because I can use both my hands because nothing is holding my phone. Look at this. Cereal box, and a cooling rack for cookies. Okay, please don't look at my super messy dining table. Anyways, here we go. So, with my genius resourcefulness here, I'm going to take this marker. It has a string attached to it. So on this marker, the string represents the radius, and I'm going to place it on this dot right here. We're going to call that the center of my circle. So theoretically, if this was, a perfect world, if I just went all the way around like this in a circle, with the marker, stretching that string in the middle tight, this should make a perfect circle because it's got that same radius all the way around. And in a perfect world where I didn't have to hold it awkwardly, this would totally work. And it's kind of difficult to do, as you can see, but we're gonna pretend and look, oh, we're doing it, yay! And going all the way around. Did it so close. Okay, pretend that's a perfect circle. Okay, so that's how you would construct a circle. But for today's section, we're going to talk about a shape called an ellipse, and I want to show you how we would construct that. So, okay, this is my new setup this time. So this time, rather than having one dot in the middle with the string attached, now I have two dots, and I've taped down the string on these two dots. And what I'm going to do is take my marker and trace around, stretching my string out all the way. So here, if I continue stretching my string out, all the way around. Do you see how it kind of made a circle shape, but it's not really? If I stretch out these dots even further so that they're farther away from like a center dot, you would see the shape a little bit more prominently. Let me show you. Okay, so I moved this end of the string a little bit further. So this was where it used to be, and that's what made this pink ring around. So this time I'm going to use purple so you can see the change. So again, I'm going to stretch out my string all the way around. Okay, not perfect, but you can kind of see how the purple one is a little bit more squished. Makes kind of like an oval shape. And this is the shape that we're talking about today. In math, oval is not mathematical enough, so we call this an ellipse. Not an eclipse of the moon, but an ellipse, like Ellipse. And so this is the shape that I want to talk about today. So in an ellipse, we have this oval shape here. It actually still has a center right in the middle, so that this distance here and this distance here is the same, but also this distance here, which is a little bit longer, and this distance here is the same on each side, but not the same as these two. Okay, so those two dots that where I taped the ends of the string earlier, those are each called focus points. But the plural version is a foci, or are foci. So when we talk about both of them at the same time, we refer to them as foci. And it's not foci, it's foci. Okay. We also want to, when we graph them out, graph out an ellipse, we also refer to these points right here on the ends. So if I drew this nicely and perfectly, all of these points right here, the center, each focus, and these points here at the ends, they should all lie on a straight line horizontally. But specifically, because this is on the longer end of my oval, of my ellipse, these are called vertices or vertex. And then vertices is the plural. And then the points right above the center and right below on the shorter side of the ellipse, this is called a covertex. So then the plural would be covertices. So these are all points that we're going to be talking about. You'll be asked to identify things like that. That's why I wanted to show you these names first. All right, so a couple more vocabulary words. When we talk about this length right here, all the way from one vertex to the other vertex, that entire length of that line right there is called the major axis. So basically we're saying that because it's major, it's the longer one. So this side from the covertex to the other covertex is called a minor axis. So if you want to think about vertices as endpoints of the major axis and covertices as endpoints of the minor axis, that would also make sense. And just like our circles, we have an equation for the standard form of an ellipse. It kind of looks like a circle. So I'll start it out so you can kind of see it. So this part should look familiar. This part was just like how we had it in a circle, but a circle had it equal to r squared. In an ellipse, it's always equal to 1. But then underneath the x's, there's always going to be a number there. So I'll call it a squared for now, but it's just going to be a number. Same thing for under the y's. I'll call it b squared for now. These two numbers are different numbers. They talk about how far you're moving to the left and to the right and to up and down from your center. So you know how before in circles we would look next to the x and next to the y to tell us where our center is? Same thing here. H and K is still our center. But this number underneath the x's, you know how when you graph, x always tells you to move left or right? So this number underneath it will tell you how far to move to the left and to the right of the center. So from the center all the way to the vertex would be that number. And for the y's, y when you graph always tells you how to move up and down. So this number here will tell you how far to move up and down to get to your covertex. Okay, so to find the foci in your ellipse, the formula looks like this. C squared equals bigger squared minus smaller squared. When I say bigger and smaller, you're comparing A and B. So whatever number A is, whatever number B is, that's what you're squaring. And then you always take the bigger one minus the smaller one. We want to basically make sure that we're never going to get a negative number here. So you always want to make sure you subtract the bigger one first. But C is going to tell you how far to move from the center to get to each focus point. However, notice how I didn't say whether you're moving left, right, or up, down, because that depends on which number is bigger, A or B. So, you know how I said A is how far you're moving left and right? If this number is bigger than this one, your focus always has to be horizontal then. But let's say the number below the y, where you move up and down, is bigger. That means our ellipse is actually going to be longer this way. And if the foci always have to be wherever it's longer, then this time you'd have to move it up and down in order to make it this way. So let me do a few examples because this is hard to visualize. All right, so first example. This is going to be our equation, x squared over 25 plus y squared over 16 equals 1. So what I want us to be able to do is to graph this. And then I also want to be able to identify vertices, covertices, and foci. Okay, so before we even start graphing, we want to be able to see what our center is and what A is and what B is. So center is where we would usually look for H and K. Next to our X's and Y's though, there's no numbers. That means our center is going to be at 0, 0. A is the number underneath the X's, so that's how far we're moving left and right. So the number there is 25. Just like with our R squared, we would always square root it, so A is actually 5. So when we graph, we're moving left and right by 5, not 25, because that would be ridiculous. Okay, so then looking at B is the number underneath the Y's, that's 16, so square root of that would be 4. So we are moving up and down by 4, left and right by 5. And then, in order to identify my foci, C, we would have to do C squared equals bigger squared minus smaller squared. So between A and B, my bigger number is 5. So squaring that would give me 25 minus 4 squared is 16, and that would give me C squared. 25 minus 16 is 9, so that means C equals 3. I know the square root of 9 is technically plus or minus 3, but because we're talking about a length of something, it can only be the positive version. Okay, so let's graph this out. My handy dandy whiteboard graph paper. So we know our center is at 0, 0. We said A, moving left and right, was 5. So that means I'm going to go 5 to the right and 5 to the left. And then B was 4, so I'm going to go up and down by 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Once I have those points down, that's basically my ellipse right there. Cool. So we want to look at, for our ellipse, which way is longer, this way or this way? Since this way, A was 5, that means the length of my major axis is 10. The length of my minor axis is 8. So my foci have to be on the side that's longer, which is this way. Okay, we said C was 3. That means from my center, I'm going to move 3 to the left and to the right because that's the direction my foci have to go because that's the longer side of the ellipse. 1, 2, 3. 1, 2, 3. Okay, so in my graph, the vertices would be these points right here because those are the ones that are on the longer side. So those coordinates would be 5, 0 and negative 5, 0. My covertices would be the ones on my shorter side. So this coordinate right here is 0, 4 and 0, negative 4. My foci on this direction, these 2 points right here, my coordinates are 3, 0 and negative 3, 0. And that's what we've identified. So we've graphed it, we've identified the 3 things. Cool, that's it. Let's do another example. So this time we'll do 64x squared plus 36y squared equals 2,304. Giant numbers. How exciting. Okay, so obviously not in standard form right now. But in order to put it into standard form, we want this number at the end to equal 1. In an ellipse, in standard form, it always equals 1. So that means we need to divide everything by 2,304 so that we get 1 on this side. And if I reduce the fraction 64 over 2,304, we're going to pretend I have amazing mental math here, because when you reduce that fraction, you actually get 1 over 36, so x squared over 36. I'm going to do the same thing for the side with the y's, so 36 over 2,304. Super mental math, you actually get 64. Okay, so now it's in standard form. We can graph this out now. For this one, its center again is at 0, 0, because I've got no numbers next to the x's and the y's. We want to be able to identify a, b, and c. So a is the number under the x's, it's 36, so square root of that will give me 6. For the y's, the number underneath is 64, square root of that is 8. And then c, we need to take our bigger number squared minus smaller number squared. So if you notice, every time you do bigger squared minus smaller squared, it's just these two numbers. And then just take your bigger one minus the smaller one. For that, you would get 28. So c is going to be 2 square root of 7 when we square root that. Okay. I'm just going to leave it as 2 square root of 7, but if we were to graph this out, we would kind of need to guesstimate and see about what number that is. Okay, so let's graph this out again. Okay, so the center on this one is 0, 0. So from that point, we're moving right and left by 6. 4, 6. And up and down by 8. Okay, connecting my dots together in an ellipse shape. Oh, there we go. Okay, so this time, hopefully you see it is clearly longer the vertical way. So that means our foci also has to be in this direction, up and down. We said c was 2 square root 7. If you do that as a decimal in your calculator, you get like 5 point something. So from our center, we're going to move up 5 and a little bit and down 5 and a little bit. So, and a little bit, 2, 4, 5, and a little bit. Okay, so identifying my coordinates again. So for my vertices, that's going to be these points this time because this is the side that's longer. So my vertices are going to be at 0, 8, 0, negative 8. My co-vertices are going to be these ones right here because it's on the shorter side. So that's 6, 0, negative 6, 0. And my foci are these two. So it'll be 0, and when I write it out, I'm actually just going to leave it in my radical form so that I don't have to write out any decimals, and it's actually preferred to leave it in radical form. So 0, negative 2 square root 7. And that's it. We've identified all the parts. Okay, for my next example, I want to do one where the center is not at 0, 0, because it's time to move on. Let's get a little bit more difficult here. So here, my new equation is going to be x minus 3 squared over 25 plus y plus 2 squared over 36 equals 1. So this time our center, not at 0, 0. Remember, we're always doing the opposite number of whatever's inside the parentheses. So if this is a -3, it'll be a +3 for our center, and then -2 for the y's. And then the a is the number underneath the x's, so it's 25 there. So it'll be 5 for a, 6 for b, and then c, we need to calculate c squared. So bigger squared minus smaller squared will give me 11. So that means c is going to be the square root of 11. All right, graphing that out, here we go. Okay, so we said my center is at 3, -2. So we'll start there. And we are supposed to be moving our ellipse left and right by 5. So 2, 4, 5, 2, 4, 5. And up and down by 6. 2, 4, 6, 2, 4, 6. So there's my ellipse. And then because my ellipse is longer vertically, that means I need to move my foci vertically as well. Square root of 11 starting from my center is going to be about like 3 point something. So 1, 2, 3, and a little bit. 1, 2, 3, and a little bit. Okay, so let's start identifying all my coordinates. I'll start with the vertices. The vertices on the longer side would be these 2 points right here. Okay, so our vertices for this coordinate right here looks like we're at 3, 4, and 3, -8. Alright, and then our co-vertices are going to be these 2 points right here. So the coordinates of this one looks like -2, -2, and this one will be 3, 8, -2. So I wanted to bring to your attention, our center is currently at 3, -2. Our vertices, we said, move up and down by 6. So I don't know if you've noticed, but if you look at our vertice coordinates, the x value stayed the same because all we're doing is moving up and down, and that usually changes the y coordinate. So if you look at your y coordinates and compare it to our center, we were moving from our center up and down by 6. So if I take my -2 and move it up 6, so add 6, I would get the 4. And if I move it down 6 by subtracting 6, I would get the -8. So that's kind of neat. Sometimes you don't have to graph it out in order to get your vertices, but I'm a visual person, so it helps me a lot. For the co-vertices, same thing. For the co-vertices, we're moving left and right by 5. So from our center, because we're moving left and right, that would change the x values. So the x value of the 3, moving left 5, I could subtract 5 to get the -2. And then to go to the other side, right 5, I would add 5 to this to get the 8. And so the other number, the y coordinate, would just stay the same. So that's kind of neat and kind of saves you some time. So looking at the foci now, we're going to apply that same method. So we're moving up and down by the square root of 11, because c was square root of 11, from the center. And that doesn't come out to be a nice number, so the way I'm going to write it is actually going to be, since I'm moving it up and down, only the y coordinate's going to change. So my x coordinate should still be 3. I'm just going to write it as 2, or -2, plus the square root of 11, and 3, -2 minus the square root of 11, because that would have been me moving up square root of 11 and down square root of 11 from the -2. So whenever you have radicals, you can write it out this way. If c is actually a nice number, then you need to actually tell me what coordinate that is without the plus or minus. Okay, and there we go. We've identified all the different parts. Okay, so moving on to other examples where we're trying to write equations of ellipses now. So just like last time, if you were given an equation where it wasn't in standard form, but we need to put it into standard form, we want to use that completing the square method again. And it's going to be similar as before. Last time when we did circles, we said move the x's and the y's together. So group all the x's, group all the y's, and then move the number over to the other side. Well, we're going to take the same steps here. So I'm going to rewrite this as x squared minus 6x, so that way I get my x's together, plus 4y squared minus 16y, and then I'm going to add the 11 over to the other side. And you'll notice I left space here next to my x's and y's so that I can complete the square. Okay, I want you guys to think back a little bit. When we complete the square, do you guys remember that rule where if you have a number in front of the x squared or the y squared, you can't actually use the formula b over 2 squared to complete the square? So that's an issue, because with the x's, it's fine. We don't have a number in front of it, but with the y's, we do. So we can't actually complete the square with the y's just yet. Instead, we're going to factor out that 4, turning this into y squared minus 4y instead of minus 16y by factoring out that 4. And then that leaves me with just looking at the y squared minus 4y. Now I don't have a number in front of the y squared anymore because it's outside of the parentheses, and now I can complete the square. And then I'm going to do the same thing on the x squared side because that one doesn't need to be factored. I don't have any number in front of the x squared. So remember the formula was b over 2 squared. So in this case, b is negative 6 divided by 2 is negative 3. Squaring it gives me 9. And this one, b is negative 4 divided by 2 squared gives me 4. Now remember, anything we add to this side, we also have to add to the other side. So I added a random 9 over here, so I'm also going to have to add 9 on this side. Here I added a 4. However, this 4 is inside these parentheses that was being factored out by a 4, which means on this side of the equation, I actually added a 16 to this side because this 4 times the 4 out front. So you have to remember, if it's inside the parentheses, you also have to multiply that number by whatever's in front, and that's what gets added to the other side. So now x squared minus 6x plus 9 becomes x minus 3 squared. Remember, this number is just the b over 2, so negative 6 divided by 2 is negative 3. Plus we have the 4 in front, and then the y minus 2 squared because this number is just the negative 4 divided by 2, so b over 2, equals 11 plus 9 plus 16 is 36. Okay, but in our standard form, we want the side to equal 1. So in order to get this into standard form, we need to divide everything by 36. So this will be x minus 3 squared over 36 plus 4 times y minus 2 squared over 36 equals 1. Almost there. We don't want this 4 there because remember, we want to reduce the fraction as much as possible. And this one is already fully reduced because I have nothing in front of the parentheses. So my final standard form answer is going to look like this because 4 over 36 is 1 over 9. Okay, so now I have it in standard form. The center is going to be at 3, 2. I'm moving left and right by 6, up and down by 3. I'd be able to find the foci real easily from here, and so on. Okay, another example that I want to do is to be able to write an equation of the ellipse given certain pieces of information. So let's say I gave you, for the ellipse, the vertices were at negative 6, negative 2, and 4, negative 2. And the co-vertices were at negative 1, negative 4, and negative 1, 0. So, if that's the only information that they're giving me, I need to be able to figure out how far I'm moving left and right, how far I'm moving up and down, in order to figure out what's going to be my equation for the ellipse. in addition to the center. So anytime I'm trying to write an equation, these are the three pieces of information that I need to know. Before I start, I'm a very visual person, like I said before. I'm going to draw this out first. Okay, so I just graphed out all the pieces of information that they gave me. They told me the vertices were here and the co-vertices were here. So I already see that my ellipse is going to look like this. But I need to know the center. So if I have it drawn out, I can just count towards the middle between these two sets of points, and that should tell me the center. If you really wanted, you could do the midpoint formula between these 2 points, and that'll give you the center. Or you could do the midpoint formula between these 2 points. Should still give you the same center. So you just need to pick one set of those points to find the coordinates of the center. But even just looking at this, I should be able to tell that my center is going to be at -1, -2. Okay? And then I need to know what A and B are in order to write my equation. So from my center, A is how far I moved left and right. So for my center, it looks like I moved 5 to the right, which would be 5 to the left as well. And then up and down looks like I moved 2. Once I have all that, then I should be able to write my equation for the ellipse. So normally we have x minus h squared plus y minus k squared over a squared and b squared equals 1. So plugging everything in, it'll be x plus 1 squared, because my x coordinate is -1, so I'm going to do the opposite, and y plus 2 squared, again, opposite. A was 5, so squaring that would give me 25. B was 2, squaring that would give me 4, and all of that equals 1. So there's my equation of the ellipse. Okay, for my last example, this time I'm going to give you 2 points for the foci and 2 points for the co-vertices. And same thing, we want to be able to find the center A and B in order to write our equation. So again, I want to be visual about this, so I'm going to graph this out first. So these are the 2 points that they gave us for the foci. I labeled it with an F just so I remind myself that those are foci and not vertices or co-vertices. These were the co-vertices that they gave us, so again, let me label that. So remember, co-vertices should be the ends of the shorter side. So if this side is shorter, that means this side has to be longer, which means our ellipse should look something like this. I don't know exactly how far it goes outwards, but I know the foci have to be inside my ellipse. So make sure that's why I want to label it and make sure I don't connect the dots that way. Okay, but even so, we should be able to figure out our center from this. So again, if you want to use the midpoint formula or you just want to count towards the middle, should be this point right here. So that looks like that's going to be the coordinate 3, 9, if I counted correctly. Okay, so now I know my center. So really, I just need to know A and B now. So I got center. Well, B moving up and down, I can tell already that I went 3 up and 3 down. A, though, I don't know because I kind of just drew this in. I don't actually know how far it's supposed to go. But remember, if they gave you the foci, that should give you a hint as to what C is. So if from my center to my foci, C then should be the distance of 4. And remember our handy little formula where we had C squared equals bigger squared minus smaller squared? Well, we know B was 3, and we know B was the smaller number because that's our co-vertices. So we know our smaller number then, squared, should be 9. We know C is 4, so C squared would be 16. Well, then I can just figure out what the bigger squared number should be. So if I add 9 to both sides, I end up with that bigger squared number is 25. And if the bigger squared number is 25, that means A has to equal 5. So now that we have all our pieces of information, I should just be able to plug this in into my equation for an ellipse. So my center was at 3, 9, so it'll be x minus 3 squared, y minus 9 squared. Under the x's is a, so that'll be 25 if I square the 5, and under the b's will be 9 if I square the 3, and that equals 1. There's our equation. That's it. That's the ellipse section. Go do your homework.